Welcome to another fun and exciting math lesson. We are actually starting Unit 5, learning about special right triangles and all those good things. Today's unit, for the most part, is review, or it should be. It's something that we used a lot when trying to find the length of lines and sides in the coordinate plane. A good refresher if you forgot. So what we're going to work on today is our Pythagorean Theorem. All right, so quick recap of our vocab. Words that you're going to hear when you're talking Pythagorean Theorem are leg and hypotenuse. Okay, so in a right triangle, the sides that form the right angle are called the legs. The legs of a right triangle are perpendicular, meaning they meet at a right angle, which we know. All right, the hypotenuse is the side opposite the right angle. So your hypotenuse is the side that's directly across from that right angle. It is also going to be the longest side in your triangle. The other two sides are the legs. So the ones that form the right angle are the legs. So underline the correct word to complete the sentence. The hypotenuse is a what side in a right triangle? Longest, always. Remember that. Your hypotenuse is always the longest side and it's across from the 90-degree angle. The hypotenuse of a right triangle can be any one of the three sides. That is false. It can't be any of the three. It has to be the longest. Has to be. So looking at this diagram, one leg of the triangle is 9 centimeters. That is true. That is a leg. My other leg is a 12 centimeters, and my hypotenuse is a 15 because that's A, the longest, and B, it's across from my right angle. So true, a leg is 9. The hypotenuse of the triangle at the right has length 15. True, the hypotenuse is 15. So what exactly is a Pythagorean theorem? Well, the Pythagorean theorem states that if a triangle is a right triangle, then this must be true. The sum of the squares of the lengths of the legs is equal to the square of the length of the hypotenuse. So if you see a triangle, it's a right triangle, then that is a proven fact. If you square each leg and you add it together, that is equal to the length of the hypotenuse squared. A squared plus B squared equals C squared. That's our theorem, where C is the hypotenuse. The converse of the Pythagorean theorem means just take it and switch your orders. We use the converse to prove if triangles are right triangles. So it's saying here are 3 side lengths. Take those 3 side lengths and determine if it truly is a right triangle. Versus the actual theorem says if it is a right triangle, then this must be true. Here we're saying, well, here's some 3 side lengths. Use that to determine if it is a right triangle. So if you square a leg and add it to the other leg squared and it does equal the hypotenuse squared, that's telling you it is a right triangle. Circle the equation that shows the correct relationship. Okay, well, taking a look at them, I can go through and do math. 13 squared is 169. 5 squared is 25. So in order for this to be true, those two have to equal 12 squared. Well, 12 squared is 144. And doing the math, those aren't accurate. So I can go through, I can do all the math, or I can just look at them, and one of them to me stands out right away. What do we say must be true about the hypotenuse? It has to be the longest side. So looking at my leftover equations, which one has it equal to the longest side? It's this one right here. 13 is my longest. Over here, I have it equal to 5, which is smaller than both the 12 and the 13. So that can't be accurate. That's not going to help me. All right, underline the correct words to complete each sentence. A triangle with side lengths of 3, 4, and 5 is or is not a right triangle because blah, blah, blah equals or not equals blah, blah, blah. So let's just do the math. 3 squared plus 4 squared equals 5 squared. We need to see if that is true. If that tells me it's a right triangle. 3 squared is 9. 4 squared is 16. 5 squared is 25. And when I add 9 and 16, I do indeed get 25. So yes, it is a right triangle. So the lengths do make a right triangle because they are equal. All right, number 8. Let's do it 4, 5, and 6. So we're saying we don't know. Are they equal? I don't know. 4 squared is 16. 25. 36. Scroll down. 16 plus 25 is 41. I did that in my head. Not equal. So therefore, they are not. It is not a right triangle. It's not a right triangle because they are not equal. All right, so let's actually use our Pythagorean theorem to find missing side lengths. So our problem says the lengths of a right triangle have lengths 10 and 24. I'm going to fill them in. We are going to use that information to find the length of my hypotenuse. All right, so I'm going to go ahead and set it up. A squared plus B squared is C squared. There's a really cool song that goes along with that. If you want to hear it, ask your teacher. Sorry. So A is 10, B is 24. It doesn't matter which number you use for which leg, meaning you could have done 24 squared plus 10 squared equals C squared. Those two are interchangeable. What does matter, though, is which one you're calling your hypotenuse. Okay, so when I do my math, 10 squared is 100. 24 squared is 576 equal to C squared. So now I'm solving for C squared. So I'm going to add them together, and you get 676. All right, now to solve for C, we need to square root each side. So C is equal to the square root of 676. And if you type in the square root of 676 in your calculator to check to see if it is indeed a perfect square, it is. Okay, it ends up being 26. Nice. So my hypotenuse in this one was 26. All right. This time around, the size of a computer monitor is the length of its diagonal. Don't know if you knew that. That's how when you go by TV screens too, if you have a 62-inch TV screen, that's the length of the diagonal. You want to buy a 19-inch monitor that has a height of 11 inches. What is the width of the monitor? So this time, if my diagonal is 19, my height's 11, I am finding a leg, not the hypotenuse. So I'm going to pause the video, work it out on my own. I want you to do the same. See if you can set up this equation and solve for the missing side. Keep in mind you're solving for either the A or the B, the leg. Pause it. All right, so typing in my calculator, the square root of 676 is 26. So I got a perfect whole number that was a perfect square, 676, which is nice. All right, I want you to go ahead and pause the video and try the next one on your own. I'm going to read through it real quick. The size of a computer monitor is the length of its diagonal, which I bet you didn't know. TVs, when you're talking like a 52-inch TV, that is the length of the diagonal. All right, so you want to buy a 19-inch monitor. 19 inches is my diagonal. The height of 11. Question says, what is the width of the monitor? So be careful. This time you are finding the x. Here is my right angle. The 19 is my hypotenuse. So A, your answer should be less than 19, and B, be careful how you set your equation up. All right, pause the video, try it on your own. I will do the same thing. Pause. There may have been about 20 seconds of duplication in there. If so, I apologize because I went and finished it all and then I realized it wasn't recording and then I could not remember where I last paused it. So I think I backtracked on this problem. Anyways, moving on, it's all good. Okay, so there's my work. Solving for the leg, so therefore I got the square root of 240 or 15.491 if you truncated your answer to three problems. Okay. Problem number 4, identifying a right triangle. So we can actually use this information to also determine if triangles are right triangles. We kind of talked about that on the first page. So not only are we using it to solve, but to figure out if it's a right triangle. So a triangle has side lengths 16, 48, and 50. Is the triangle a right triangle? Explain. So which one are we going to use to help us? We're going to use this one because number by itself is the biggest number. That's your hypotenuse. This one is not. This one is not. Okay? So all we're going to do is solve the equation, see if the two sides are equal to each other. So in order for this to be a right triangle, 16 squared plus 48 squared has to equal 50 squared. 16 squared is 256. 48 squared is 2304. And we're saying that those two, when you add them together, have to be equal to 2500. So that's what we're trying to determine. Well, when I add them together, I get 2,560, which is not equal to 2,500, which means that no, those numbers do not represent a right triangle. So the equation is false. It is not a right triangle. All right, let's move on to the last page. Oops, sorry. See, totally already did it. Okay, so we're going to talk about Pythagorean triples. Pythagorean triple is a set of 3 numbers that will create a right triangle every time. They are special ones that always work. Okay, numbers that people have found that always work. I'll get done in a minute. Okay. So one Pythagorean triple is a 5, 12, 13. These have a special relationship. Now, I can't just plug together any 3 numbers, but I know that 5, 12, and 13 work. So I can check that by plugging them in. I know that 13 has to be the hypotenuse, the one by itself. So 5 squared is 25. 12 squared is 144, and that equals 169. Then I say 169 equals 169. Check, yay! See, it works. Told you. Okay, why are they helpful? Well, they help us because if we recognize one, it's a lot easier to do our work. Okay, not only does a triple create a right triangle, but any multiple. Meaning, if I take my 5, 12, and 13 and I multiply them all by 2, 5 times 2 is 10. 12 times 2 is 24. And 13 times 2 is 26. So 10, 24, 26 is also a triple. If I multiply my 5, 12, and 13 by 3, 15, 12 times 3 is 36, 13 times 3 is 39. That is another triple that works. So any multiples of it as well work. All right. Another very common one is your 3, 4, 5. Very commonly used. 3 squared plus 4 squared is 5 squared. 3 squared is 9. 4 squared is 16, and 5 squared is 25. All right, so those are your Pythagorean triples. If you use them and you see them, it can help you. For example, if you have this triangle, 3 and 4, and you're trying to find the hypotenuse, 3, 4, 5, that's a triple, it works. What you have to be careful of is something like this. If I gave you 4 as a side and 5 as a side, don't automatically assume that this is 3. Can't happen because A, your hypotenuse cannot be shorter than the other sides, and B, whenever you're looking at the triples, the biggest number always represents the hypotenuse. The legs are interchangeable, but the longest number is always your hypotenuse, so be careful. That does not work. Okay, so last thing of the day. Don't look. Oh, I erased it. Okay. So a triangle has side lengths 16, 34, and 30. Your friend says it's not a right triangle, and look at your friend's work and describe the error. So taking a look at what my friend did, you may be able to find the error already. Ooh, sorry. Let's walk through it if you can't see it. So the directions say underline the length that your friend used as the longest side. Well, they used 30. Yes, we know that's not the biggest number, but what represents the longest side is the number that's by itself on the other side of the equal sign. So they used 30. The bigger number really is 34. So the equation they should have used was 16 squared plus 30 squared equals 34 squared. So what did our friend do wrong? They used the wrong side as a hypotenuse. Bad friend. All right, we are done for today. See you later.